Okay guys, we'll see to it. I guess this Excel is visible. Now we are going to see how this quickshot algorithm is going to work. I told you clearly that this quickshot name is not, since this particular algorithm is quick, just a name given for it. Don't assume that since the name is given as quick, this algorithm will be faster. The only difference is whenever you are speaking about merge shot and quick shot, both are going to follow divide and conquer approach, but this particular quick shot does in place replace operation. But in case of merge shot, each and every time memory is allocated and memory is deallocated. This is the only difference. Okay. Here, let us assume there are few values. How will you arrange it? Sorting is nothing but arranging data in order, right? So, in case of quick sort, we'll see how to arrange the data. So, let me give some values. We'll take an array where it consists of 10, 80, 90. I'll give some random values, guys, okay? 30 and 20. So, considering about this array, so we are going to consider the value which is sorted. So, considering about this array, I can say that this value in a sorted position, right? Where this particular value is the lowest value in this particular array. So, I can say this value alone sorted. If at all I say, if I take some other array like this, for example, 6, 3, 5, 4, 2, 1, 9. If I take array like this, I can consider in this array the value, this element as a sorted value, right? Because what happened, the overall highest value is placed at its appropriate position. So I can consider this person as a sorted element, isn't it? The same way, if I give one more, I'll give one more explanation, guys. I'll tell you the reason why you're seeing about all those things. There is some reason behind seeing about all those things. I'll tell you what is that. 4, 6, 7, 10, 16, 12, and 14. If I take this as an array, I can say that this 10 is at the sorted position. Isn't it? Yes or no? Yes, right? The element whatever towards its left side is smaller than this. Whatever the element towards its left side is smaller than this, and whatever the element towards its right side is greater than this, right? So what does it mean? This element is placed at the appropriate position. So I'm going to consider this element as a sorted values. So we are going to implement this quick sort based on this logic only. We are going to consider the array. Okay, we are going to take an array and we are going to take one position in an array. The particular position can be of any position. It can be either beginning of an array position or end of an array position or in between value of an array position. You are going to consider some value as your pivot value. We'll be considering as a pivot or some sorted values. Just the terminology is given as a pivot. There is nothing name behind it. Okay, meaning behind it. Okay, just we are considering one element as a sorted element, taking the particular element as a sorted element, and we are going to arrange the value. Okay, so we are going to bring the particular value to the sorted position. This is what you're going to do here, guys. So quickshot is nothing but you're going to take an array. You're going to take an array and you're going to consider the, and in the particular array, we are going to consider any element in the array. And we are going to make the particular array where this particular element, let me have a small example, guys. For example, guys, are you clear so far? We are going to take an element and bring to its appropriate position where all the elements towards its left side should be smaller until all the elements towards its left side is smaller and all the elements towards its right side should be greater. If at all this process is going to be done again, this is the process of your quick shot. Whatever the value you're going to consider to arrange, it might be either beginning or mid or end. It can be any position. You're going to take a element and you're going to bring the particular element to the appropriate position and inserting this particular element which will make this particular array as where all the elements towards its left side will be smaller and all the elements towards its right side will be considered as a greater value. Okay, first I'll give you the naive approach of how does your quick shot works. Then we can go ahead with the logical flaw. Okay, first you should understand how this is working. Now let me consider some example how it is working. So let me consider an array with values 1, 7. Let me consider some values, guys. 1, 7, 3, 5, 2, 6, 4. Let me consider array with this values. So how many values are there? 7 values are there, right? So let me consider this as an array. And the index position of this array might be 1, 0, 1, 2, 3, 4, 5, and 6. This is the index position. As I told you that we people are supposed to consider one element called pivot. And this element, whatever you're considering, might be a beginning element or end element or mid element. It's up to you. You can consider any element as your array as your pivot value. Either you can consider the first element as a pivot value or the last element as a pivot value. It's up to you. And right now, I'm considering the last element as a pivot value. So what I'm going to do is I'm going to do I'm going to do some operation where I'm going to insert this 4 up the appropriate position. So if during my insertion, what happened? I'll bring auto the value which is less than 4 at here. The element which is less than 4 will be brought towards left side. The elements are which are less than 4 will be brought towards left side, and the elements which are greater than 4 will be brought towards right side. This is the operation you are going to do it. So this is the logic behind this quick shot, guys. Take a pivot value, bring all the value which is less than the particular pivot value to its left side, and take all the elements which is greater to it towards its right side. This process has to be continued again until the data is sorted. So considering this particular 4 as a pivot value, right now who is pivot? Pivot is considered as 4. So based on this, we are going to make an arrangement. So let me have the same array here. So what happens? The elements which is less than 4, let me write roughly here. What are the elements which are less than 4? 1 is less than 4, 3 is less than 7 is not less than 4. So directly I'll go to 1, 1 is less than 4, 3 is less than 4. Okay, yes. And after this, after 1, 3 is less than 4. After this, 2 is less than 4. Yes, 2 is less than 4. And 6 is not less than 4. So all the elements which is less than 4 has been picked, right? 1, 3 and 2. And I'll insert 4 here. So this is the position of your pivot value. Guys, I didn't go logic for it. Just I'm giving a naive approach. How does your quick shot works? Taking all the value which is less than 4 and putting before to it, it doesn't mean that all the value towards your left side, whatever you are taking, should be arranged. It is not arranged. Just I'm bringing the value which is less than your pivot value towards its left side. We are not going to arrange it. Just moving the data alone is going to happen. And the same way, whatever the value which is greater than 4 has to be brought here. So the greater than 4 from the beginning is 7, and next value is 5, and the next value is 6. So right now this could be the position of the values after bringing all the values towards values less than 4 towards its left side and greater than 4 towards its right side. So this is the exact position. So this particular 4 is considered as a sorted element. Right now 4 is sorted. Your pivot value has been sorted. And this process has to be done repetitively. So for the next time, what you're going to do is, for the next time, you're going to take your left array alone. This particular array alone you're going to consider and you're going to arrange it. So if at all you're going to consider this value alone, 1, 3 and 2. We'll never disturb this 4 because this 4 is already at the appropriate position. Don't disturb it. You'll be at this position. Right now, who is taken as a pivot value? Right now, let me give some other color for pivot. So again, I'm going to take this person as a pivot value. So for this left array, what I told you, the left rightmost element will be taken as a pivot value in an array. So this is your one sub array where this element will be taken as a pivot value. And now all the elements which is less than 2 will be inserted at your left side, and all the elements which is greater than 2 will be inserted at your right end. So this is going to happen. So what happen if you are inserting this value, you will be getting 1, 2 and 3. Isn't it? 1, 2 and 3. and this particular 2 is inserted at its appropriate position. Right now, this is considered as a sorted values. This is considered as a sorted value. Right. Now, left of 2 is completely arranged and your right of 2 is also completely arranged. So this process is done. And after this, right now only one value is there. Again, this value will be considered as a pivot value, no more data. So same way for a right hand also, no more data is there. Right now, this particular array data has been sorted. So this particular divide approach will be happening until the data reaches single values. So continuously dividing it and you made this one. The same way if at all you're going for a right hand. So right now I can able to come to the conclusion my left side has been sorted. The data whatever it is on my left side I'm going to treat it as a sorted values. This process has been happened continuously. And same way I'll take a value from this side. So I have 7, 5 and 6. 7, 5 and 6 and here which value will be considered as pivot value? The rightmost value. Who is that? 6 will be considered as your pivot value here. Pivot is 6. The value whomever is less than 6 will be brought towards its left side and greater than 6 will be brought towards its right side. Right now I can able to come to the conclusion the particular 6 has been brought to the appropriate position. There is no more value to it. No more value has to be sorted. Right now, this person has considered as a sorted value. So these values are single elements. So I can treat this particular array as a sorted one. Is this clear, guys? This is a naive approach. I didn't go anything logically. I did just rough calculation part. How does your quick sort works? The logic is take an element from your array at your right end or left end is up to you. I'm taking at your right end and taking all the element whomever is greater than the particular pivot value to its left side. And if I find that no other values in my particular array which is less than this, then I'll insert this value. Then I'll bring all the values towards this right end. Is this logic clear? This is how your quick sort works. Come on. Okay. Okay, fine. We'll write the logic of it, guys. So we have seen the naive approach. We are going to see logical wise. Whenever logic comes, we'll come here. I can have a parallel calculation of it. Now we can go into the editor and we can do the process, whatever is required. Now, just a minute. We'll go to the editor. As I said you guys, there is a difference between merge sort and quick sort. Both follows divide and conquer approach. But in case of merge sort, each and every time memory is allocated by using dynamic memory allocation. But in case of quick sort, in place replace is done. This is the only variation. Okay. Now we'll go ahead with the implementation part. Let me command these lines. Okay. Hash include stdio/h and followed by your, let me declare an array. Let me declare array of size 10. Tentatively, we can accept size from the user later on if required. Okay. Let me give size and right now I'm going to accept size of the array and enter size. And after this, we'll accept it through scanf percentage d. I guess captures on. Okay, percentage d, comma, and that's now size. After this, we can accept input from the user for array. So for I need an iterator. So let me declare an element for iteration for I assign 0 and this I is going to be executed until it is less than size followed by I plus plus. So inside this, what you're going to do, you're going to accept value for this array. Scanf percentage %d, comma, like I can mention ARR plus I. I guess you people could remember this ARR plus I. Instead of array of index, I can make use of pointer arithmetic, right? Even you can accept input value by using pointer arithmetic. And followed by it, so let me call my function. My array has been accepted, everything is done. Now let us call our function quick short. Quick short. So when you're calling this array, what are the important element required? Which is the array you're going to work with it? And here what you're going to do is continuously you're going to divide it, right? So what I'll do is I'll take my starting position and take my ending position as my parameter. Either you can take the size of the array as parameter, or you can take two parameter. One is your lower parameter, another is a higher parameter, higher end parameter. The higher end parameter is size minus 1. So let me give size minus 1 here. So now let us go ahead with your function definition. Right now we are going to see with quick short. So let me have void quick short. Your first parameter is going to, you're going to supposed to accept the array's base address. So let it be. And next is you're going to accept the integer value. So let me give it as lower index value. I'm accepting it. And next is size minus 1 is nothing but my higher index value. So let me accept as high. We are accepting this one. So until which you're going to perform this division operation. Until which you are going to perform this division operation. This division operation has to be performed until your lower index is less than your higher index. So this partition has to be happen again and again. So first we'll see how does this partition happens. Then we can study the condition. So what you're going to do is for this quick short, I'm going to write one separate function called partition. So you're going to you're going to partition the particular array, right? So let me write one function called partition. So let me write int one variable. For my pivot value insertion, I need this value. So let me mention int pi and followed by, I'm going to write one function called partition. Partition, and here I'm going to pass three parameter. One is array and followed by a lower index and followed by a higher index. By passing three values, I'm going to perform partition operation. So now we are going to write logic for how to perform this partition. Int, this function has to return some value, right? So we are going to store in a variable. So let me have int partition. Let me go ahead with my function definition. So now guys, this partition logic here, I'm not going to write here. This partition logic will go to the Excel, will write parallelly. How does it does? Then only you people will be clear with it. So I'll copy this, we'll go to the Excel part, just a minute. So you're going to write logic for partitioning. I'll do one thing. I'll share my entire screen and I'll have notepad on this as a parallel one. It's not possible guys, just a minute. Okay. So this is the array, right? This is the array we are considering, and here we are going to perform partitioning. So what I am going to do is we are going to first consider what is the pivot value. Right now, who is the pivot value? The last element, which is nothing but the size. We are passing the size. We are having one element called low. He is initially 0, and we are having. Let me remove all those things, guys. Just a minute. And we are going to have one more element called high, and this element is size minus 1, which is right now 6. Let us consider this as an example. It will be easy to trace it. Okay, this is your low and this is high. Right now, who is considered as a pivot value? This particular highest value has to be considered as a pivot value. So let me write logic here. Int your pivot value is considered as array of your highest position value is considered as your pivot value right now. And after this, and I'm going to set a pointer, guys. What I'll do is I'll have a 2 pointer and I'm going to move from one position to other position and slowly I'm going to trace it out. I'll let you know what I'm going to do it. I'll have one position called I pointer, which is mentioned as low minus 1. So what is low here? Low is already 0. So I'm going to have one pointer called I where I'm going to start the particular person. Let me do one thing, guys. Just a minute. I'll take a separate sheet for this Excel. It will be a little confusing if I'm typing here along with it. I'll take a new sheet for explanation, guys. Give me a second. I'll paste it there. We'll take this example there. Okay, this is the one and followed by this one. I'll take these two. Sorry, guys. Okay. Right now, what is your high value is considered as? Your high is 6 and your low is 0. High is considered as 6 and your low is considered as 0. And what we are told is, and pivot value is considered as array of 6. Sorry, array of 6, which is nothing but 4 value is considered as a pivot value. And as I told you that I'm going to have one pointer called I, who is nothing but low minus 1. Initially, this I pointer I'll be keeping this I pointer as low minus 1. And apart from this, what you're going to do is I'm going to traverse until my low is less than or equal to y, where your low will be 0 and I will be 6. Until my low is less than or equal to high, I'll traverse it. So until 0 to 5, I'll traverse it. I'll take all the elements which is less than this value and place it towards this left side. So I'm going to have one loop. For the particular loop, I'm going to have one variable called j. Now we'll have a looping process. For my j value starts from my low n and my j value is going to be executed until the particular person is less than or equal to high minus 1. Either you can mention less than or equal to high, or you can mention less than or equal to, so less than I, or I can mention less than or equal to high minus 1. Both are going to give you the same meaning and followed by j plus plus. Clear? Now what I told you is I'm going to start my iteration from here to here and I'm going to check what are the elements which is less than 4. Further I've taken a loop and here I'm going to have my condition part. In this condition part, what you're going to do is you're going to check for each and every iteration if at all my array of j is less than or equal to your pivot value. So what I'll do, I'll check whether 0 is less than or equal to pivot value. No, it is not less than, right? So if it is not less than, don't do any process, go up and directly increment your j pointer. Is that clear? If it is not lesser, it is not lesser, right? So initially a j pointer is here, my j pointer will be move here. Is this clear? I'll check whether array of j is less than or equal to my pivot value. If it is not equal, directly don't perform any operation. Go up and increment your j value since your j loop will be executed until my j value less than or equal to minus 1. So for the next iteration, your j pointer will be moved to the first index. Right now at the first index, who is there? Right now at the first index, 1 is there. Now I'll check whether 1 is less than or equal to 4. Yes, 1 is lesser. So if it is lesser, what should I do? I should bring this person to the 0th position, right? So he is lesser, so all the elements which is less than 4 has to be started from this particular end. So what I'm going to do is I'm going to do one operation, that is nothing but I'm going to increment my I pointer. Initially, where is my I? He is at minus 1, right? I'll bring my I pointer to this position. So let me have a graph of it. It will be easy for you people to look at it. So this is your ij pointer and this could be your I pointer. So right now I'll increment my I pointer. Then what I'll do is I'll ask these two persons to perform swap. Is it clear? I'll ask these two persons to perform swap. So here what I'll do is I'll call my swap function. Swap of what are the elements has to be swapped? Address of array of I. Whom does I points to? Right now I points to 0th position, right? So address of array of I and address of array of j, I'm going to pass it. So I'm going to pass it as a call by reference method. Or if you want, you can do the swap operation here itself. In order to make your code understanding, I'm writing separate logic for swap in a separate function. It's up to you. Either you can write your swap logic here itself. Now, I'll mention this swap logic aside, guys. It is nothing great. Normally, everyone knows about swapping, right? So, I'm going to write swapping here. You can mention void swap. And here, we are going to receive two elements as a two elements address, right? So, let me declare two pointer variable here. Int of star A, comma, int of star B. So I'm receiving two variables here, and as usual normal swapping method. You can have one variable called safe, and this safe assigns star of A. Guys, star of A is important, don't forget it. The reason behind is you are receiving as a pointer type. So star of B and followed by star of B assign your safe value. So this is done. So whenever this swap operation has been is called, so this element will be gone there. So what happened? These two element is going to be swapped. Right now what happened after performing swap operation? 7. Let me write the logic and the value which is swapping here. It will be easy for you to understand later, guys. I'll write here. 1 comes here and 7 goes here. So now this is a modified value. Your 4 will be at the same position. No changes at the fourth position. Right. Now again, after doing this one, after doing this operation, what I'm supposed to do again, my j pointer increments. My j pointer increments here, he'll be coming here. Your j pointer will be here. Right now I'll check whether 2 is, sorry guys. Right now I'll check whether 3 is less than 4. Yes, 3 is less than 4. So what happened? Again your I pointer increments, swap of array of I with array of j. So I pointer increments in the sense your I pointer reaches to the next position. Right now your I pointer comes here, and what happens? Swap of array of j with array of I. So what happened? 2 comes here and 7 goes here. Isn't it? And again your j pointer increments to the next position. So I'll check whether 5 is less than 4. No, it is not less than 4. It is not less than 4 in the sense this if condition will never be executed. It will go up and your j pointer will be again incremented. So once your j pointer increment, it comes here. So your j pointer position is this. So previously it is incremented, right? So it is incremented and checking, and right now your j pointer will be coming with one more step. Guys, is that clear? We forgot to increment it. So this two values is going to be, did we leave any values, guys? I guess this to be 2. I mentioned this index position. Sorry for it. The value should be 2 should be there, right? So 3 should be there. Isn't it? 3 and 7 will be swapped. So 3 goes here and 7 comes here. Fine. And after this a j pointer increment here, this 5 and 4 will be compared. 4 is less than 5, so no swap. Your j pointer will be incremented. It's automatically come to this particular position. Right now what happened? 2 is less than 4. Your value will be compared again. 2 is less than 4. Yes, 2 is less than 4. So what happened? If 2 is less than 4, again increment your I pointer here. Yeah, I pointer will be incremented and these two values will be swapped. These two values will be swapped where here 2 goes here and 7 comes here. Is that clear? And after this, again after doing this operation, your j loops increments. A j loops increments in the sense your j loop comes here, and right now I'll check. Right now I'll check whether 6 is less than 4. No, it is not less than 4. It is not less than 4. until which this particular loop will be executed j less than or equal to I minus 1. So until this process has been completed, right? So you can notice that the value 5 will be here and the value 6 will be here. After bringing all the values, this is how your operation, this is how your array will be. Your I pointer will be at this position and your j pointer will be at this position, and this is how the operation after first partition, right? After first partition, this is how has to be. So right now I have brought all the elements which is smaller than 4 towards this left side, and here I have brought towards the after I position I have brought all the values greater than towards the right side. Now I should bring this value at this position. Which position? At this position, which is nothing but I should swap this array of I plus 1 with my high position. This operation has to happen. For this, what I should do is after completion of this loop, I should write one logic, which is nothing but I should call my swap operation, swap of ampersand of array of I plus 1 has to be swapped with ampersand of array of your high value. Is this clear? Okay, so these two value will be swapped. So what happened? 4 comes here and 5 goes here. So at the end of this operation, we can able to find out that the value has been brought to its appropriate position and this data is sorted. Here, now this data is sorted. After this, what I'm supposed to do? I should take this as one my subarray and this as my another subarray, and this process has to be repeated. So if you want to repeat this process, what is required? This index position is required for me. Right now, this index position is required. So at the end of this function, I'm supposed to return my I plus 1 index position back to my quick short function. Is it clear why I'm returning it? So if at all I know this index position only, I can able to take this one as first half and this one as a second half. Again, I can continue the process again and again. So for that, this index position is required. This index position is I plus 1. I didn't modify my I plus 1 pointer. Just I'm keeping as such. Whenever I want to access it, I'm mentioning as I plus 1. So that is the reason I'm passing returning I plus 1. Is that clear so far? This is very simple, guys. That is the reason I'm tracing along with the example. Writing the code and tracing along with the example will help you out to find out the flow of the program. Okay, now I'll take this logic and we'll paste there and we'll execute and check it what is happening. Okay, now we'll take this logic there. We'll copy this. Give me a second. We'll go to the editor. So this is the one we are doing it, right? So let me paste it here. And meanwhile, swap logic also has to be copied. So let me copy swap logic also. And let me place this swap logic above to it. So swapping is done fine. So let me give some indentation, guys. Fine. And here, let me complete this one. Since we are written concentrated only on logic, we didn't see about the syntax. We'll see all those syntax and indentation. Meanwhile, then I'm checking with the program. So these statements should be given with the indentation and followed by the for loop should be inside the function. These statements should be in. Let me remove this one. Okay. These statements should be given inside it. And meanwhile, these statements which belongs to this for loop, right? And these statements which belongs to each statement. So this is done. And followed by your swap. Done. Now in this quick shot, just what is this partition PI requires? It finds the appropriate position where the particular value has been inserted. Right now, I can notice that before left side towards this particular index value, all the elements are smaller, and right side towards this index value, all the elements are greater. Now what I'm supposed to do is I'm supposed to call this quick short again and again by passing some values. Let me see what is that values you're going to pass it. You're going to call this quick short by passing the array, and what I'll make it as two separate half, low and my index whatever are thrown there, the particular value minus 1, the pivot index whatever you swap, it is not required to consider. So I'll take a range as my left half. If the fourth position is the position where the pivot value has been inserted, you're supposed to take only from 0 to 3, right? So you can mention low to p minus 1 or 5 minus 1, what are the variable I have mentioned it, and this as my one of my parameter, and I can take the next half. The next half can be considered as array, comma, your pivot index inserted position plus 1 as your starting index and followed by high as your ending index. Is that clear? So this is a process which is going to happen again until which this process has to happen, until your low should be greater than your low should be less than high. Until your low value is less than high, I want these process to be repeated again. Is this clear, guys? Until this process only, I want this particular operation to happen again. I can notice that for each and every time your low and high will be varying based on your pivot value, based on the breaking of the array, right? So first your high value will be at n minus 1 position. Second, your high value will be only from the mid value. You can notice the high value. Let me show you by using Excel, guys. Listen here. Just a minute. Okay, considering this example, initially a low value is here, high value is there. And the next time what you're considering this as your low value and this as your high value. Again, this as your low value and this as your high value. And the next time when you're breaking off, what happened? Again, this value will be again sorted, right? You're going to sorted it where this particular value is going to be taken, and where this is your low value and this is your high value, and 2 will be inserted and 3 comes here, right? And after this, when until my low value, when both the person are equal, and the low, when we keep on doing until it is a single element. Yeah, you can notice that low is equals to high. Again, when you're doing it, what happened? Your low remains as such and your high will be crossing it. The same as we did for binary search. So until your low value is less than high value, I'm going to repeat this process again. So this is a condition I've written here. Is this clear? Why I have mentioned here low value is less than high value? Do you have any doubt in it? Okay, fine. I guess you people are clear. Now we'll execute this program. It is very simple, guys. Only the logic wise when you're saying that it will be too hard, but it's very simple. Understanding the concept is very much important. Now we'll execute this one. Did we use header file? We didn't declare the header file itself. Okay, fine. Is anything missing? We'll check to it. Every parenthesis is nested properly, right? Let me check with the nesting, guys. Everything is done proper. Here, nesting is missing. Okay. Your for loop, your if condition closed here, and your for loop has to be closed here. This closing is missing. Okay, guys, let me share you the output window. Just a minute. I guess the output window is visible. Let me give value 5. We'll have value 12, 3, 4, 10, and 5. I guess we didn't print it. We have seen the logic. Did we print it? We forgot to print it. We'll print it and we'll execute it again. So we'll print it, guys. We concentrate only on the logic. We failed to print it. We'll print it here. After this, you can put in for loop for your I value, assign 0, I less than your size, and followed by I plus plus. And inside this, let us print it, printf percentage %d, comma, array of I. Let me give some spacing during a print. Okay, done. Now, printing is done. We'll go ahead further. Just a minute. Let me share the output window. Okay, fine. Now let me give the size as 5. We can give value 2, 3, 1, 5, and 4. The data has been sorted. Can have a glance of this program, guys. If at all you have any doubt, you can let me know. It is so simple. Whatever the logic I told you, the same logic we did as a program. If at all you have any doubt, just let me know. We'll see to it. No doubt. That's clear. Okay, good. This is the main logic behind it. Continuously you're doing partition of it. So hence we'll be saying divide and conquer approach we are using here. Okay guys, fine.